Sorry, I just need a couple extra minutes to get back upstairs. I sent something to scan and yeah. So anyway, welcome. Thank you for coming, guys. I really didn't want to teach myself, so thank you so much. So this session is to go through our midterm. And then I believe we picked, I want to say it's next Thursday. Does that sound right? Next Thursday again at 7 was after some sort of exam. I don't even remember which one. So that's when we're going to take out questions that you have about the final and, do some final exam, kind of review. Okay. So as always, just email me questions. If you have any questions between now and when we meet next Thursday, just send me an email. If I don't answer, I sometimes every once in a while I'll miss one. So just send again if I haven't answered in about, a day and a bit. Sometimes I can't answer that actual day because I have doubles so much right now. But, if I don't answer within the second day, then please email me again because then I've missed it and I don't want to miss anybody's email. Okay. So you guys do have, the midterm actual file, I guess, is on OWL with solutions. So I think it's just like A, B, D, kind of the answers. I'm just going to, I had Alicia kind of type it out without anything written on it because I know your exams have writing all over them. So we're just going to go through each question and just unmute and ask anytime you want. Okay. All right. And I did send you guys a bunch of stuff, so I'm hoping everybody got it. Just some stuff for reviewing. So if you didn't receive my email yesterday, then please send me an email so I can try forwarding it. I found that a couple people's things have been going into junk for my stuff, so I'm not sure what to do about that really. Okay, so for number one, we had, I just want to make this a little bigger for you guys, okay? So if you guys want, the exam without your writing all over it, you could, screenshot 1 and 2, and then when I move it up, screenshot 3 and 4, and if you want to practice it again later type of thing, okay? So identify the linear equations. Okay. So remember, for linear, we need that, we basically need that we would have all the things in front of, the U prime, U double prime, all of those would have to be just functions of only t. Okay, so for linear, let me maybe just get some blank paper to put over this, just so that I don't have to squish it in, if you know what I mean. Okay, so for example, in A, I like all my U prime, U double prime, everything like that. I like it to be on the left, so it's already like that. So it's just a 1 in front of the U prime, and then over here, so this and this, they're only t's, which, if you wanted to write the U prime as du by dt, you could, just to see that that's the bottom variable, or, we can say the kind of, this is the dependent, this is the independent. So in this case, we want everything in front of U prime, U double prime, U triple prime, whatever, to be only t. So this one's good. This one's linear. It doesn't have 3u minus 7, right? So it's okay. B, let's see. Okay, I don't like the form of B, so I'm going to move it all over to one side. So if I bring this across, then I'd have nothing. So let's take a look. In front of each of U prime, U double prime, etc., is only functions of t, which this doesn't have any t's, but that's okay as long as it's just numbers. So yes, that's linear. I know they didn't ask for it, but if they did ask about it on your final, then this is your q of t, and it's not 0, whereas this is our q of t, which is 0. So which one's called homogeneous, guys? Who remembers? Which one's homogeneous? Anybody? Yeah, good work, Mateo. It's homogeneous here when we just have 0, right? And so this is homogeneous, just in case they ask that. Okay, let me put C in order. We've got U prime Oh, this one's weird. Look at it has u prime times u. So in other words, that's kind of like just saying u times u prime, isn't it? So that's a 1. But then this one, in front of one of our derivatives, this is not a function of t, right? So u of t, negative, is not just, numbers and t's. So therefore, it's nonlinear. We only talk about homogeneous and non-homogeneous, inhomogeneous, if it's linear. So we wouldn't even talk about that. I know you didn't need it for this question, but okay. So let me write D. D is e to the, I'm just going to pull this down so I can see. E to the negative t, u prime of t squared. Ugh, this one looks weird. T minus 1 squared u of t. Okay, well, we don't have powers of u prime, u double prime. So that's definitely going to screw that up, right? We can have u double prime, but not, u prime squared. So that's going to be non-linear. And so the next one is E. Let's see. E is u prime prime of t over t squared. Well, let's just write that as 1 over t squared because that kind of looks more normal, right? And then we've got sine squared t u prime of t equals cos t. So if this cos t had a u beside it or a u triple prime, I'd move it across, but I just leave it if it's just the term without a u or a u prime or u double prime. So that's a t. That only involves t. There's no u's. That only involves t. So yeah, this is linear. Okay, so question 2, I'll just show you here, is it's got pt equals negative 1/3 pt minus 1 plus 2 with p naught is 9, and we want the limit t approaches infinity of pt. So for me personally, it's a multiple choice. I'm definitely going to use the shortcut. I know it's the more obnoxious question because there's 2 numbers, right? So if there was just this, it would be the easier type, wouldn't it? So this means that A is negative 1/3 and B is 2. So my formula is PT is P naught minus B over 1 minus A to the T plus B over 1 minus A. So we have everything. So P naught is 9 minus 2 over 1 minus negative 1/3. So that'd be 1 plus 1/3. And then A is negative 1/3 to the T, and then 2 over 1 plus 1/3. So 1 plus 1/3 is 3/3 plus 1/3. So that's 4/3. So that's 9 over 1 minus, now this would be 2 divided by 4/3. So that's like 2 times the reciprocal. So that's going to be 6 over 4, which is really 3/2 then. So let's just write it like that. And then this would be the same number, but plus. Okay, so let's do common denominator of 9 and 3/2. So that'd be 18 over 2 minus 3 over 2. So final answer would be 18 minus 3, so 15/2 times negative 1/3 to the t plus 3/2. Now, it didn't ask me for the explicit, formula. It said, what's the limit? So I'm not quite done, right? So now, I don't think I can quite fit it there, but so limit of t approaching infinity of this mess plus 3/2. Okay, well, so the question is, what is this, right? Is this infinity? So then it's infinity plus 2, which is infinity. Or is it 0? And then it's 0 plus 3/2 is 3/2. Well, depends on whether the number is, in absolute value larger than 1, right? So if this was like 2 times 2 times 2, infinitely many times, that would be infinity. Or, negative 2 would be the same thing, right? Because it's still going to be a big number, right? But because it's a fraction less than 1, or I guess you can think of it, less than 1 in absolute value, or kind of between -1 and 1, negative a third times negative a third times negative a third is just going to be, a smaller and smaller decimal. So this approaches 0. So this times 0 is 0. So the limit's just going to go to 3 over 2. Okay? 3 over 2. Now, just so you know, the order of the exams were all different, so A, B, C. So this might not be in the exact order that your particular exam is, but all the questions are the same. They were just, out of order. Okay. Okay. So what's number 3? The volume of a sphere increases by a factor of 8. By what factor does its radius increase? So that's backwards, right? We're used to them saying, if you increase the radius by 8, what does your volume do? So the volume of a sphere is 4/3 pi r cubed. So they say volume is going up by 8 times, right? A factor. So there's kind of different ways you can do this. Like you can think about what's the relationship between r and v originally. So if I cross multiply, I get 3v equals 4 pi r cubed. So r cubed is 3v over 4 pi. So one way to do this would be to say, well, if I take this and I put 8v instead of v, then how do these compare, right? So, if you wanted to cross multiply again, you'd get 24v, and you'd say 24v over 4 pi is r cubed. And so your choices, 24 over 4, by the way, is 6, right? So your choices are, you can do that. And anytime you want to factor of anything, you probably did this in high school, you can divide the two and see what do they go up by, right, in terms of a factor. You could also do it where you say, what's your r originally here, or what's your v even originally, and look for the factor there. So it's up to you. So what I did was just said, okay, what does the r cubed factor, what's it going up by, right? So I said, okay, r cubed is increasing by whatever this is, when I divide these, right? So that's dividing by a fraction is multiplying by the reciprocal, and I get the v's cancel, the pi's cancel, and 24 over 3 is 8. Now you have to remember that that's r cubed, so r is going up by a factor of 2 times. Okay, now the other way I could do it is to say, I'm trying to think here, my brain's phasing out. So what did I do? I know I wrote it a different way too. So 4 pi r cubed, 8 times the volume. So I guess, so 8v and then the original v. So I guess I could say, if your v is 4/3 pi r cubed and you're making your v 8v, then I don't know what's easiest way to write this for this one. I'm going to have to think about that. Because, if this is being multiplied by 8 from the original, if you're just taking 8 times this, then you're really doing, 8 times 4/3 pi r cubed. And so, I don't know, I just kind of think of this, like if this is going up by a factor of 8 to be, the original v, then I just kind of think of this that if that's your original v, then to be 8 times the volume, I think of, what number cubed is going to be giving me something 8 times bigger. Yeah, but I'm sure there's a better way to write that out. I'll have to think about it. We'll get back to you on that one. Okay. I like dividing them. That's my preference for sure. Okay, now number 4. So if you want to take a picture of 3 and 4 blank, they're there. So what's 4 want? The solution to this equation. Okay, so, well, if we're looking at the solution there, then, what kind of question is this? Well, we have like a dy by dx, right? So if we have a dy by dx, then that's basically just a differential equation, right? So I would just see, is my equation separable, or is my equation linear, or what's our other option? Bernoulli, I suppose, right? All of those are, things that we did. So if I say this is dy by dx equals, some of you didn't mind the y of x, some of you, left it. Some of you would just say this is y squared because maybe you didn't really prefer that. So it's up to you. So is this one separable? Well, this one would be, right? Because I could just put the y squared on the bottom of the left. And then I could just keep the dx kind of up on the right, right? So dy over y squared equals 1 dx. All right, so we would say, well, it's not going to be a ln, so be careful. We don't want it to be thinking it's a ln, because anything that's not just a single y cannot be a ln, right? So we'd say y negative 2 dy, and then we'd integrate. So the integral of y to the negative 2 is going to be what? Y negative 1 over negative 1. Integral of 1 is x plus a constant. So you know me, I like to sub in my constant then. So that's x and that's y. So, but they're both 1. So 1 to the negative 1 over negative 1 equals 1 plus c. So 1 over 1 to the 1, that's just 1. So divide by negative is a negative. So c is negative 2. So that means that my equation from right here, so y negative 1 over negative 1 equals x minus 2. Okay, so this is like negative 1 over y. And then we could say, well, we could switch all our signs. So 1 over y is negative x plus 2. And then, let's see, our y, well, I like to just kind of treat that as something over 1. So y would be the flip of that. So 1 over negative x plus 2. I think in their answers they wrote 2 minus x, which is obviously the same, right? Yeah. Okay, so for question 5, so let me show you 5 here. So there's 5 and 6. So this one was one that I thought was actually pretty ridiculous. So this, I'll highlight the ones that I think are ridiculous. So this one I think is insane. They're just really mean. So the population grows according to n prime of t is Rn of t. Okay, that's not so bad. But then look, n of 3 is 27 n of 0. So 27 times your original. How many time units are required for your population to double? So that's really hard. So what I would start with is, n of prime is like, n prime of t is like dn by dt, right? So I'd start with that. And I can separate it. So I can say dn over n equals r dt. And then I solve it. So the integral of 1 over n is ln of n. But I don't need an absolute value because in the question, we would know that since it's talking about population size, then we know that, we can't have a negative size, right? So n is positive. So we don't need to worry about the absolute value. integral of r with respect to t would be rt plus c. So if we have a ln, then to get rid of it, we're going to e everything, right? E both sides. So e to the ln n equals e to this. And this one has that trick that I showed you and said, make sure you know this, it always comes up, right? So the e's match its n. And then remember I showed you that you can break this up using your exponent rule, so you need to obviously do that here. Now, at that point, our equation is some constant. E to the c is still a constant. E to the rt. But unfortunately, that wouldn't have got you any mark because it's multiple choice. And then they told us that n of 3 is 27 n of 0. And then, even more so, then it's like, what was it? How long does it take to double? Like, this question takes like 2 pages of my writing. So if I take a look at this equation for n, or n of t, well, if this is your, n of t, then n of 0 is going to be c e to the 0, which anything to 0 is 1, so that's just c. And then if I do n of 3, it's going to be c e to the t is 3, so 3r. And it tells me that n of 3 is 27 times bigger than n of 0. So if that's n of 3 and that's n of 0, then I have to say, okay, well now this one, c e to the 3r, is 27 times this one, which is c. And my c's cancel. So at that point, I can find the constant r. So I can ln both sides. Bring this down. Ln e, we all know, is 1. So r is the ln of 27 over 3. But you're not done, right? You're not done because, and then it says, what's t so that the population now has to double? Okay, so I'm going to write this equation and my r on the next page. I'm just going to put my r in, actually, right? So if n of t was c e to the rt, and r was ln 27 over 3. So now I'm saying double it, right? What's t? Well, that means if I start with c, doubling would be just 2c, right? So if I have this, oh, don't forget the t there. I forgot my t. So then I can say, okay, bye-bye c's, divide both sides by c. And then guess what? I gotta solve for t. Well, to get rid of an e, I'm gonna ln both sides, right? And it's not even just a matter of doing that. Like I said, it's utterly ridiculous. So we bring this down because it's a ln. Ln e is 1. So if I want t, let's cross multiply. So 3 ln 2. And then so t is 3 ln 2 over ln 27. But of course, that's not even the answer, right? Look at your answers for number 5. So then we have to just change a base. Put this up, right? And we could, I guess I could leave the 3 there. Oh, I couldn't because I'm using change of base. So I would have to change them both from, they're both e's to 3's. Because then I could work out the bottom, right? Why am I doing ln instead of log? Log. So here, this is like log base 3. So that's 3. Oh, actually, maybe I can just leave that. So from this, if I do the 2 cubed, that's ln 8 over ln 27. Yeah, so I don't need to change the base. I mean, I could, but I think this is faster. This is ln 2 cubed over ln 3 cubed. So now I can just bring the 3's back down and cancel them. Like that. So final answer is ln 2 over ln 3. Isn't that insane? I just think that's nuts. Like, really? One multiple choice mark? No. Yeah. So that's strike one. Okay. This one was not hard, but certainly a lot of time, right? So for which of these problems does u of x equals this solve? So, I mean, you could check the initial conditions to see if they work in the equation. And I think that narrows down maybe one or two, I can't remember. So let's say for, we've got u of x is e to the x plus x squared. So what would u of 1 give us? And that would be, if x is 1, e to the 1 plus 1, right? So that doesn't work. And then I think it's u of 0 is 0 that doesn't work, because u of 0 is e to the 0 plus 0. E to the 0 is 1, so that's 1. So those are not the right, if I put u of 1 in there, I don't get that, right? In terms of my equation. Now, you can't actually solve it because if you try and solve it, so I looked at it just to see out of curiosity if I write du by dx, but it actually ends up involving integration by parts, which you guys don't know. So A and B don't work because of the conditions. Now, if I look at C, the initial condition does work. So if it puts 0 in here, I know that I get 1. So I know that one works, right? And then I know that my u of x in the question is e to the x plus x squared. So if you did the derivative of this, the derivative of e to the x is itself. The derivative of x squared is 2x, right? Okay, so look at the derivative that you got from your equation and just check left side, right side and see if it works. So the left side is u prime minus u. Well, u prime is here and u is here. So the e to the x's cancel. I get 2x minus x squared. So this is, seeing if something is a solution to equation. So that, I think we covered that in the very first section of the course, right? So 2x minus x squared. So left side equals right side. So that one works. And then if you try other ones, like I think parts D and E, I'm pretty sure they don't work. So only C was the answer. So let's say I show you E maybe. So u prime of x for E, it says equals u of x plus 2x. It does have the same initial condition, so that's fine. But the left side, well, we just did the derivative and we said it was e to the x plus 2x. But the right side is u plus 2x, and our u was, in the question, e to the x plus x squared. So see how they're not the same? So that's a no-go. So it ends up only being the 1. But, time consuming, right? Oh, this was the other that, this one is so ridiculous. And when I looked at the exam, I didn't even know this was ridiculous because it's just a straightforward question, right? But they didn't give you the answer. Like, it was so, so mean. I'll show you what they did and you'll be mad for sure about this one. So we know that we can just get our equation. So, we did in class, like y equals kx to the m. We ln everything, right? We separate the logs. We did this a whole bunch of times, right? Oops, ln of k. And then, it's a product, so we can break it up and then bring the m in front, right? So I'm sure we remember that, right? And then we know that from that, we know that m was our slope, which is rise over run. So most people, did the rise over run, great. So up 1, right 2. So a half. And then they just looked at the graph and said y-intercept is 1. Great, no problem. And you know that your y-intercept is ln k, right? So if we know that y-intercept is 1 and it's also ln k, we just set them equal. So this is what we did in the ones in class. Fine. Exponential form, ln is log base e to the 1 is k. So k is e. Great. So then you wrote your equation, which is normally y equals kx to the m. But they said, let's use a and b just to mess with you. So, okay, fine. Then it's got to be b equals k a to the m. Okay, so fine. Put the k in, put the m in. So you get b equals e and then a to the 1/2. And you go, okay, I'm done. And then you look at the answers. B equals e a to the 1/2. And you go, no. Right? And of course, some people just picked B because, they found the half and they found the E and they didn't know what else to do, right? So here's the deal. What they did was, this is your equation. It's like a y equals is B equals, and then they solved it for A. Right? So yeah, like just ridiculous. So how do you solve this mess for A? Well, you could solve for a to the 1/2 and then square both sides, or you can square both sides right away. I don't know what's easier. I just squared both sides. So I said b squared is e squared, and then a to the 2/2 is just a. So a is b squared over e squared, and then they brought it up and they wrote it like that. Right? All right. So that's strike 2. By far, 5 and 7 are by far the hardest midterm questions I've ever seen on those 2 types, right? Okay, so then number 8. So we've got a differential equation, okay? And it says it's dg by dt equals g over t. Okay, so then it's just saying, assuming both G and T are greater than 0, what's the blood glucose concentration, right? Is it linear? Is it exponential? What is it, right? So, a lot of people just, I think, looked at it and said, okay, it's linear, right? I actually just, wrote out the solution to it and then just, saw that it's linear, but maybe people can just tell by looking at it, I guess. So I did like dg over g equals 1 over t dt. And it says g and t are both positive. It says greater than 0. So it's just ln g equals ln t plus t, but I don't need any absolute values because of that whole, they're both greater than 0, it says. So e to both sides is just, well, that's just g, and then this is e to the ln t, e to the c, and then this is just t. So it's just g equals some constant times t, which is just a linear relationship. So it's just linear. Okay. So there's our 9 and 10. So if you want to take a picture of that, if anybody wants it. Okay, so this one, I wrote a note on this when I wrote up the solutions. I can't remember if I sent you guys the solutions to this yet or not, but I can send them if I didn't. Does anybody know if I sent them? guys get the solutions yet to this? Okay, well, I don't remember, so no, not yet. Okay. Okay, remind me to send them then. I'll pull them up now so I can remember to do that after, okay? So in the solutions, I was mentioning that this question, like number 9, looks very, very much like a midterm question that we went through in prep that I had put in the prep package for the midterm. And it looks, very, very close to it. But this one, well, for once on this exam, this is actually an easier one because if you find the midterm one, so it'll be in the prep final package too. I actually can't remember which one it was. But anyway, the question in the actual midterm one, we didn't have the derivative. So we had to do a lot more work. But for this one, it's actually already the derivative explicitly as dn by dt. So we don't have to do much work for this one. Even though it looks the same, it's not quite the same. Because, just trying to get paper here. So because we have this dn by dt equals t times 0.5 plus sine 2 pi t. So what's this doing at 0? Well, you know that if your derivative is positive, right, increasing, derivative negative, decreasing, and derivative equal to 0, then not increasing or decreasing. So what happens is in A, if you put 0 in here, you get dn by dt is just 0, of course. And so is it decreasing? No, that's false, right? If you put b in, t is 3/4. Well, 3/4 times 0.5 plus sine 2 times 3/4. So that's going to be 6/4. So that's 3/2. So that's 3 pi over 2. All right, well, just, plot your sine graph, right? So what's the sine of 3 pi over 2? Well, that's going to be here. So that's -1. So I've got 3/4, a half minus 1, that's -1/2. So that's less than 0. So decreasing, so B is true. Okay, what's C? Decreasing at 1/4. So if you wanted to check that, I don't know if you guys go in the order that things come or not. So you'd have 1/4 and then sine 2/4. So that's sine pi over 2. So that's 1. So 1 plus a half, that's positive. So what do they say for C? Oh, decreasing. So this is increasing. So it'd only be B then, right? Yeah. Because there's a none of the above, but there's there's nothing else that it could be. Yeah. Okay. So 10 is probability. Okay, so this one was really easy, in my opinion, because it has E, F, and E and F. So we already know from class that you cannot possibly ever have mutually exclusive and independent at the same time, right? So we know that to say both is just nonsense. Are they mutually exclusive? Well, if they're mutually exclusive, then E and F is 0, right? That's mutually exclusive or disjoint. So E and F is 1/8. Well, that's not 0, so therefore they can't be mutually exclusive, right? Because E and F is 1/8. Has to be 0 if they were mutually exclusive or disjoint. To check independence, we talked a lot about this, right? We talked about the difference between the two. So if they're independent, then E and F is E times F. Now you can also, if you knew that E given F was just E, that would also be independent, right? They don't affect each other. E given F happens just E, but we didn't have any given. So we're stuck with this one. So we just check E times F is a quarter times a half, which is 1/8. And they told you that E and F had probability 1/8. So yeah, they're equal. So yes, therefore they are independent. Okay, so it would be independent and not mutually exclusive. So that was B, independent and not mutually exclusive. Okay. Okay. So for 11, it's talking about dn by dt, and it's talking about the long term, right? After a long time. So when we're looking at long term, and we've got some differential equation, dn by dt here, well, I'd probably just, draw a quick sketch and, find your equilibrium and look at what's going on your graph. So if we have, we did a bunch of graphs like this. So if I set this equal to 0, we know we can factor n minus 1, n minus 3. So our equilibrium is 1 and 3. So you can either, do a chart, you can do test points like that, whatever, you can draw the graph. I just drew a quick sketch. So n and dn by dt. So I know it crosses the horizontal at 1 and 3. And then you can put another test point in, like put 4 in here. That's positive at 4, right? 4 minus 3 is positive, times 4 minus 1 is positive. Put 2 in, 2 minus 3 is negative, times positive is negative, and you can get the quick sketch, right? So then you can do your arrows. Above the horizontal is to the right, and below is to the left. And I forget what they wanted. Oh, long term. Okay, so if you start at 0, 2. Well, remember, if we start at 2, 2 is there. What do your arrows say you're going to do? Well, they're pointing this way, so we're going to go back until we get to the equilibrium. So we're going to go back to 1, right? Until we get to 1, and then that's an equilibrium, so we would stop. So that would be C. Okay, 12. So that was another probability. That one's pretty easy. So all you have to do is just kind of use your formulas for that one, right? So we've got E given F, F, and E. We have them all, right? So let's say I write out the given for E given F. Then I can find the and. So the given on the left is 0.4. The and we don't know. And F is 0.5. So if you cross multiply, then you knew that E and F was 0.4 times 0.5, so 20. Okay, so that's true. Now, E and F and E are always the same, right? They're just the middle. We talked about that in class as well, so that's true. So because E and F and E are identical, right? Now, F and E is E. Well, F and E and F are 0.2. E is also 0.2. Okay, so they must all be true then, right? Now, let's say that you didn't have the choice of all of them and you just wanted to know if A was true. Well, then F given E would be F and E or E and F. Same thing, but it has to be over the given one, which would be E. So E and F is 0.2 and E is 0.2. So that's going to be 1. So that would be your answer for that one. Okay, so for 13, so again, this one's not too bad. This is just working with sets. So you know me, I like to write down all the complements before I look at it. So if E is 1 to 3 and all my numbers are 1 to 6, then not in E would be 4, 5, 6. And if F is 1, 3, 5, then not in F, 1, 3, 5 is 2, 4, and 6. Okay, so what do they want? E and F complement, union E and F. All right, well, let's do E and F complement first, and E and F, and then combine it, right? In E and not in F. In E and not in F. So in other words, that's in E and F complement, right? In E and not in F. So what's in both of these sets? One's not, two's in both. And that's it, I guess, right? So that's the number 2. Okay. In E and in F. So look at these two sets. What's in both of these two sets? In E and in F. So 2's not, 1 is in both, and 3 is in both. So that's 1 and 3. Now they want the union of those two. So E and F complement, union E and F. So a union, remember, is in one or the other or both. Just don't listen to anything twice. So it would just be this and this combined without listening to anything twice. So just be 1, 2, and 3. Now, what if it was an and here instead? So what if they wanted E and not F and E and F? So that would be what's in both of them, and that would be nothing. So that would be the empty set, right? The set of no numbers. Okay. So the probability ones are actually really straightforward on this exam, ironically. Okay. Oh, so that's 13. Okay. So 14. Due to gene dosage effects, even diploids can carry more than 2 copies of the same allele. So an organism inherits 0, 1, 2, or 3 from its mother, and they're all equal, and they can inherit 0, 1, 2, or 3 from father, all equal. What's the probability that this organism inherits 2 or fewer in total? I would draw out the sample space. I would just say that you can get 0 from mom, 0 from dad, 0 from mom, 1 from dad, 0 from mom, 2 from dad, all the way up. And then you get 1 from mom, 0 from dad. And I would just write them all out. I know it takes a bit, but I mean, it takes you really like 20 seconds, right? It just gives you a visual. So I want 2 or fewer total. So the 2 numbers have to add to 2 or less. So I can't have anything adding above 2. So add up to 2 or less. That adds up to 0, 1. That adds up to 2. That's too big. Adds to 1. Adds to 2. Too big, too big. And that one, I guess. So that would be 1, 2, 3, 4, 5, 6 cases out of 4 times 4. So 6 out of 16. Divide by 2, 3/8. So E here. Okay. Okay. 15. Population of rabbits has brown, white, or gray, dominant or recessive. So plus is dominant, negative is recessive. Oh, this one is one that I thought was hard. I didn't like their wording. I feel like it was tricky wording that people would not have realized that it was a conditional or given. It says, based on the information, what is the probability of randomly selected from the population with dominant gene, a rabbit with gray fur? So they're saying from dominant, get gray fur. So what they're asking you for is gray fur given dominant. But I just thought that was a bit tricky. So it'd be gray and plus, over the given one, it's plus. So gray and plus is 20%, and then plus would be just add up all your pluses. And I mean, you can do decimals or fractions. I just did decimals because I thought it would be quicker. You know, because 20 over 100, like I just think that's going to be more work. I just did it at the end to a fraction, but yeah, so add up the 3 pluses. So I just said that's 0.20. When I added those three, I got 0.60. So then I just moved the decimal twice and just said 20 over 60 is a third. So okay. Oh, wait, is it A? Oh, I think, oops, Alicia typed that one wrong. Yeah, it's definitely 1/3. Yeah, I'll have to tell her to fix that. Yeah. Okay, so 16. I forget what this one was about. A veterinarian evaluating 2 horses. A has probably a 0.1 getting sick in the next year. Oh, yes, I remember this one. Okay, this one's actually really easy. B is estimated 0.2, and then it says both is 0.5. And then it just says, what's the probability of either or both? So they're just asking you for the union there, right? So the probability of A or B or both is just your union formula. So it's the probability of the first plus the probability of the second minus the probability of first and second. So it was 0.1 for the first horse, 0.2 for the second, and minus both. So 10 plus 20 is 0.30. So 30, just think money, 30 cents minus 5 cents, 0.25. So D. Okay, I'll have to remember to tell Alicia to fix that. Code. Okay, so we've got this. So we're just going to evaluate this. So do cos of 0. 1 star means times and 2 means exponents. So, cos of 0 on your graph. Cos graph starts up at 1. So it's just going to be 1 plus 1 is 2. So it'll show up as 2.0. So B. Okay, 18. Okay, running the following lines of code. Okay, so we've got 0, 1, 2. And it says A equals A plus 1, and what's the output? Okay, so if it's printing A and it's not tabbed, then it's only going to print your last number of the loop, right? So is that one is not tabbed. Okay, so my loop 1 is starting with 0, so it'd be 0 plus 1, which is 1. My loop 2 is put this in, so 1 plus 1 is going to be 2. And then my third loop, because there's 3 here, it's put the 2 in for A, so it's going to be 3. So your output is just going to be 3. So C. Okay, now when we've got the 1, 10, 10, linspace print x of 1. Okay, so the first number is a 1. The last number in our set of numbers is a 10. And they want 10 equally spaced numbers. So start at 1 and go to 10 and space them out equally. 1, 2, 3, 5, 6, 7, 8, 9, 10. There we go. Okay. So if we go from 1 to 10, this is called x of, the first number is called x of 0, right? So they want you to print x of 1. So x of 1 would be printing the number 2, so 2.0. So B. And what's this one? This one is just evaluate this, so kind of like the coast one. So it would be pi plus 1, so 3.14 plus 1. And I don't know all the decimals to pi, but find the one that looks like that, right? So D. That's something I don't have memorized. I know some people know like 30, 80 digits of pi, but I never saw the point of that. Okay. So now the ridiculously stupid question, in my opinion. I know my opinion doesn't matter, but I'm just telling you anyway. So in this question, so normally you do, of course, you're in and you're out, and then, you know, just make your equation, which isn't usually too bad, but this one is crazy. Okay, so I'm just going to do in and then out, okay? So the in, let's see. Consider a chemostat containing a liquid with volume V. So first of all, my volume is not like 1,000 liters this time. It's V in liters. And then we've got, this is flowing in at this rate. So, you know, we usually do in times in. So we can still do that regular thing. It's just, it's 10 milligrams. I don't like this liter -1. I always write it, you know, per liter, as you know. So I'm going to do that. And then it's milliliters per second, right? So the first trick is our units do not match. So if we convert this to liters, I've got to move it back 1, 2, 3. So it's 0.01 liters per second. And now I get 10 times 0.01, I guess, right? So that's what, 10 times 1 over 10, 100? So 1/10 milligrams per second. So that's my rate in. Now the out, well, remember we do in and then minus y out over volume, right? So out, well, let's see what it tells us here. Population proportional to, so the population of microorganisms consumes nutrients at a rate proportional to the nutrient concentration. Okay. And the rate constant associated with nutrient consumption is K measured in second -1. And then it tells us, I remember there was something somewhere about the mass. Oh, so at T equals 0, the chemostat operator switched from a nutrient solution made from green to one made with red. Developed, do not solve differential equation. With side condition, initial condition for U of T, find the mass of red colored nutrient inside at time T. Okay. So the flow out is, it's just going out at the same rate, right? Flows into, yeah, okay, so it's just going to be your same 10 milliliters per second. And then usually we call it Y, but this time they very specifically said that it's U, and it's over volume, which is usually like 1,000 liters, but this time your volume is V. Now, your units do match because U is always in grams or milligrams, and the volume they did tell us was in liters. So if we convert the milliliters to liters again, 0.01 liters per second times U of T over V, milligrams per liter, and we do get milligrams per second, right? So 0.01, I know you can just leave these both as decimals if you want, or you could say that's 1 over 100, right? So that's milligrams per second. Or you could say U over 100 V. So that's your flow out. And then they talk about rate of consumption of nutrients. So that was lovely, and a lovely addition. And so they said it was a constant K. So So if you have K times your U, but really it's going to be a negative K because consumption, and it's milligrams per second as well. And at T equals 0, the initial condition would just be there'd be 0, right? So what's your final equation? Well, if you put all that in and out to get your equation, then the model would look like, U of 0. Oh, I can't write. U of 0 equals 0. So your derivative would be, well, you had in was 1/10 minus out was U of t over 100v, and then still minus the k times U of t. So that would be your model right here with that initial condition. Or in decimals. Your choice, right? Okay, 22. A rare disease has prevalence, okay, of 0.002. So, you know, I always do D plus for has the disease, D minus for doesn't. So 0.002, then it's 0.998. A test has specificity of 0.99. So I always do T plus means the test came back positive, and T minus is the test came back negative. So if we've got specificity 0.99, so that's your probability that the test came back negative given you didn't have the disease. So that's there, which means this is 0.01, so they add to 1. And sensitivity is 1, so that's the probability the test was positive given you do have the disease. So if that's 1, then I guess this one's just 0, right? Sample, okay, consider a population of size. Okay, so there's 2,000, people. Okay. What is the expected number of people who have the disease in the population? How many true positive tests are expected? Okay, so if we have 2,000 people and the prevalence of the disease is 0.002, then we would have 4 people that we expect to have it, right? Whatever the disease is. True positive tests. Well, a true positive is the probability that the test comes back positive and you do have it. So that's the probability of 1. So the number of true positives would be 1 times those 4 people. So all 4. Now B, in the same population, how many false positives? Okay, so the probability of a false positive is that your test says you have it, but you don't. So take a look at your tree. Test positive given you don't have it. So that is there, 0.01. So the number of false positives is 0.01 times n, where n is the number that don't have it, right? The number that without the disease. So we had 2,000 people in the population and 4 had it, so 1996 don't have it. So 0.01 times 1996 is just about 20 people. Okay. And that was which part? B. B. C. An individual in this population is tested for the disease. The test comes back positive. Explain in words whether it's more likely that an individual has the disease or the test is wrong. Okay, so we had 4 people had a true positive test, and we had 19.96 people had a false positive test. So if you just got told that you have the disease, it says which is more likely. In words, is it more likely the individual has it or your test is wrong? Well, this one's much greater, right? So if I got a positive test, it's much more likely that I'm in this group of 20 people than this group, right? Yeah, so it's more likely that the test is wrong. Now, when I made up the final booklet for prep, I added a million questions, and one of them I added was this style of question, but with all the different parts of everything they could ask. So, true positive, true negative, false positive, false negative, how many of each of those, etc. Okay, so the last one was Bernoulli, and it was actually an easy Bernoulli for once. Thank goodness, because of those 3 multiple choice that were ridiculous. So it was an easy Bernoulli. Assume X and Y are both positive. However, it was marked insanely. So if you didn't get the initial equation, I saw people that got 0 and they knew how to do Bernoulli completely. So that was extremely bothersome. So I've never seen them marked like that, so I don't know what's going on this year. But P of X would be everything in front of Y. So that's P of X in the original. And this together, both of those would be Q of X. And we know it's Bernoulli because we have Y to an exponent, right? So our U is Y to the 1 minus N. The N is the exponent there. So it's just going to be U is Y to the -1, right? Okay, so my Bernoulli equation that I have to memorize is du by dx plus 1 minus n u p of x equals 1 minus n q of x. So 1 minus n is -1, so it's du by dx plus -1 u times this p of x in the original is like 2 over x equals -1 x squared sine x. So the initial equation they were looking for you to give would have been du by dx minus 2 over x times u, or u of x, equals -x squared sine x. So now when I go to do this linear equation, p of x is everything in front of the u, and q of x is everything on the right. And so my integrating factor is e to the integral of p of x. Of course, if you don't have the negative, you're going to get it wrong. So it'd be e to the -2 ln x. X and y are positive, so this doesn't matter. I can just put it as ln x -2, which is just e to a ln is just x -2, right? I don't need any absolute values. And v of x, u of x is the integral of v of x, q of x dx. So let's see, my v of x goes on the left, so x -2 times u. And then on the right, I've got x -2 times the q for the linear, which was -x squared sine x. -x squared sine x. So no product rule, of course, for antiderivatives. So we've got to multiply. So let's see. It would be negative. Here we get x to the 0, -2 plus 2, x to the 0, which is 1. So it's just the integral of negative sine x. Okay. So then we have to just integrate that, right? So it's quite a long process, isn't it? It takes a while. All right, so our initial condition was y of pi equals 1, and I had u as y to the -1. All right, so let me just write this again for a sec. Okay, so derivative sine x is positive cos, so answer is negative cos. So I've got negative of negative cos, so really I'm back to a positive, which is kind of nice. And y of pi was 1, and u was y -1. So if y is 1, then u is just 1. So I can just put x is pi, and u is 1. So pi to the -2 times 1 cos pi plus c. So that's kind of weird, right? 1 over pi squared. cos of pi is -1. So C is 1 over pi squared plus 1. So that can go back in there. So I've got, sorry, the one before it. So I've got x -2 times u is cos x plus, that's my C. And then I've got to just solve that. So my u was y -1. So I don't like dividing by x to the -2. I would just times everything by x to the 2 here. Because of course this would make it x to the 0, so get rid of it. Then my u is just x squared times this big mess. You don't really need this bracket here. Whoops, that's a square, 1 over pi squared. Okay, so I'm basically done. That's my u, which is y -1. Y -1 is like 1 over y. So if 1 over y is all of this mess, then y is to flip it and put 1 over that. Like that. Whew, that was crazy, eh, guys? Okay, well, I hope that helped for you to see me going through them all. So I would, go through the midterm again, try doing them all again, just write them out like without any numbers or anything written on them, and, see how you do now, okay? And make sure that you've fixed all your silly mistakes if that's what you did on some of them. Obviously, 3 of them were quite difficult, but other than those 3, yeah, just make sure you fixed anything that you went wrong on, okay? Okay, does that help, guys? You're welcome. You're welcome, guys. Okay, so email me if you have questions in the meantime, and otherwise, I will see you next Thursday. Good luck on all your exams, you guys. I know you have a lot coming up. How was chem today, guys? It was good? Oh, good. Well, that's a relief. One more down and a whole bunch to go. My husband will probably do it tomorrow sometime, yeah.